Hello and welcome to another fine evening of Evening Rust. I guess I was a little bit redundant, I had to say that differently. Nonetheless, we're back today, and today we're going to do a bit of scoring. Scoring means what we were trying to do yesterday. We have our bots, and we just construct all the moves of the game, and now we have to reconstruct those moves and figure out scoring and figure out what the best move is. Hey Johnny, how's it going? To start the day, as we always do, we're going to jump off over to our, what is it, Clash of the Code. And we should use start, unfortunately the first one we have to wait a few minutes. And I'm going to disable the proxy because we'll need that for later. And I still haven't figured out how to configure it correctly, so I don't need to turn it off, but it's okay. So yesterday we're still doing Code for Life. And like I say, we got all the turns deconstructed. I went off and asked some questions in a Rust forum about how to do certain things. The one bit I did get, which was helpful, was we have a weird syntax, which we were discussing yesterday, which we didn't like. So we have this where we have to take this reference here. And the reason given why we have to do this is because, and what was it? Because it's this is an array. An array just doesn't implement into iterator. You can't iterate over an array, but for whatever reason, a reference to an array does implement into iterator, and you can iterate over it. But this forces you to do point T. But what I was told is you can probably do pattern matching like this, and take these off, and we'll see if that actually works. That looks like it works. The RLS doesn't complain at us. So there's a good chance that actually works, and that's pattern matching then. I can't find any reference in the docs that says you can do pattern matching in for, which is a little bit weird. It's for let, if let, match, and something else, but I couldn't find for. It's just a bit weird. Okay, we're going to do our add stuff again. I see we have Jasper in the list there. It's great. Compete against Jasper. Just going to post this over here. And we're going to go off to General DE, and we haven't posted the German one for a while. Just don't post it there every time because there's not much chatter, and then it ends up being there multiple times at once. So what else do we have? We have Mindlek today and Milan. We don't know those people. I don't think we've played follow them. We know Jasper. Jasper's the guy that makes this plugin for us to actually use an external editor, so it's great. And what else do we have? What else are we going to do today? I was thinking about the scoring problem a lot, and I'm still not entirely sure how we're going to do it because I haven't worked with the expected values before. And I'll get back to this again later, but basically when we're running around this lab, we have various things. We can pick up a recipe, and it's worth so much, but only after we fulfill it and turn it in. So it has like potential value. It's not, so it's an expected value calculation. Hi, Ngoyen. And so this expected value calculation is a little bit uncertain, because if you have a recipe and it's going to take you 10 moves to do it, somehow we have to say, well, that's worth a little bit less than one that has the same value but takes 8 moves. But at the same time, we can't overvalue these things so you don't take higher value recipes. So we're going to have to figure that out. And we'll go through the basics first and get it there. And we'll get there right away. We're just waiting, again, anybody joining us, we're just waiting to play this game. And Coin's joining us as well. And he's usually pretty good at the stuff. I expect him to beat me. And again, we're either hoping for not golf is a key thing, or a really confusing question. We do good with the questions confusing as well. Alright, let's see what we have today. Oh no, not this one, reverse world. And I have to figure out what it's printing here. Whatever it is printing it forward and backwards. Now, string stuff really sucks in Rust so far. It's interlaying it too. So it's taking the reverse string, it's printing first string, next string. So it's taking the two strings and interlacing them together. So we just need a way to reverse this, and I have no idea how to reverse a string. Let r equal s dot charge.reverse.collect. I just want to see if this works first of all, if I have the reverse string. S and R. Let's see if we actually get something. No, we did something wrong. Reverse, or maybe it's just rev. Cannot infer type. We'll just say this is a string. Okay, holiday, e-holiday. Okay, so that looks about correct. So now we're going to do for I in 0 dot dot. Actually, we're going to collect this as a vector of char, and we'll just say s prime here, s prime, and then let s e a vector of char as well equal s dot chars dot collect, because we have an issue. You can't index over a string. r.len, and for each one we're going to print not a print line. We're just going to print nothing. We're just going to print the two characters, and this is going to be si-ri. Let's see if that works. Find value s in the scope. That's fine. Equals s prime. Did we get it right? Looks good. So I think we got that, and we're a bit slower on there because that one is actually, I don't know why we're slower, but okay, we did well enough. 2-boot JavaScript. This is, let's see what they did. What on earth is that? I don't even understand what he's doing. In JavaScript, replace anything dot with G, A, P. So it takes an index somehow. So it takes the index and replaces it. Interesting. So it's doing a quick... I wonder how he came up with that so fast. That's very interesting. It's using a regex. That's really cool. What did Jasper come up with? Just went over the length. I guess we could have done it this way as well. We should have just realized we could do that. But I wanted to reverse it. And what did Anycoin? What did you come up with? That looks like almost the code is identical. Really? Okay, you have slightly different variable names, but otherwise you're pretty much the same as Jasper. And then we can publish our code too. We did it ridiculously, but that's okay. So we fell far behind in this one. I still have no idea how the points work in this game. So that's all. When we started it, let's go on to competition mode. Where were we? We're over in Code for Life. Gonna join here. And we're going to open up the external editor. Use the previous. I'm going to upload the file to IDE. So you saw that previous button there. That's the reason why I always do a git commit before I do. I did that git commit yesterday, so I didn't have to. Just in case I pressed the wrong button. I don't want to get the wrong code. But I synchronized the code as well. And I actually submitted the random code. And this is hilarious, is that we're rank 50. And this is the random code. I don't recall from last time. By random code, what I mean is that each turn, we did the best scoring. So get best turn goes and scores each turn and does the best one, except the scoring function just returns a random value. And it's surprising that we're not dead last. So we're actually more than halfway by doing random behaviors. And we think this is primarily because there's a lot of bots. People may have just given up this level, or there are a lot of new people that haven't got the rules quite right yet. And so most of those cases we win, or probably all of the cases we win, are because we just didn't die and they made a mistake. So today we actually have to implement this score function. Now, as I said, scoring is difficult because if we look at the game end, yeah, Reknakas, yes, exactly. That's what I'm guessing, is that they just time out, do something wrong, and that's how we win. And but what's surprising is our random one isn't doing any worse than our one that actually tried to do something intelligent. So that says a lot about the level of competition beyond us. So let's look at the screen again. When we have these stations here, and they have this silly logo in the place now. I wish it would go away. These robots move around and go away, silly logo. Just play my code then. And I'll try to explain it a bit better. if it plays, and if the silly logo goes away. There you go. And, oh, slow this down. So we have, like the robot, we're carrying these recipes, and the only place you actually get points is over here, and this is called the health points. There is science projects, but we're just cleverly ignoring them for now. Well, not cleverly, stupidly ignoring them. And so you only ever actually get points over here. But the point is that you collect potential points here. There's potential points here, and this is a big mystery box. This top one here, the samples place, is a big mystery because you don't actually know what you're going to get out. You can do ranges. And over here, when you analyze the samples, then you suddenly have ideas. Well, what points am I going to get for them? And for each of these points, you're like, okay, this is your potential. Like if it has 20 health on it, you can get 20 health. But before you do that, you have to go down here and collect your molecules. And that puts some variation in here. It's like, well, how much are these things actually worth? When I have a recipe that's completely filled, over here, it's worth full value. But if I'm over here, it takes time to go across. So it has to be worth slightly less. And the reason it has to be worth slightly less is to ensure that if there's a second recipe here, a second sample, that we actually pick that up first and try to fulfill more than one at a time. And so I'm not entirely sure how we do the scoring, but it's going to be very important we sort of count that we have reduced values, and the score includes the fact that you have to move around. And my initial idea was to say, well, let's take a score per turn. So if I have a value over here at the, just go back a step or two. If I have a value over here at the diagnosis, I have a thing, and it's going to take me 1 turn to walk here, 4 turns to fill up, and another 2 turns to go over here. So that's like, if I have 20 health over 10 turns, that would be like a score per turn of 2 or something. And obviously we're going to look for any way that can improve our score per turn. So if I could pick up 2 recipes and fill 2 of them up and bring them over and save some time, the average score per turn would be a little bit higher than that. And I'm not entirely certain how we do this. We're going to have to just play around a little bit. I don't think we'll have to do too much work to get to Bronze League other than just do some basic scoring. And let's at least do the basic scoring, like if we have something in hand, we feed it to the laboratory to at least get away from the random stuff. And so the basic scoring is basically going to be if I have nothing in my hand, well then having something is going to have a higher value. That's clear. We don't have to worry too much about that. And when you have 3 things in your hand, it's very clear to see that adding more has no value because you can't do it, so it's not even going to come up. And collecting molecules, you have nothing is also good, but molecules on their own are worth nothing. So basically, if you don't have an analyzed sample, that's the highest priority, highest health. So let's start with that. And I appear to be losing my voice a little bit today, so sorry about that. So the score thing again, now, we have a lot of this redundant code, and, well, not redundant, but it's a lot of pattern code. Oh, and yeah, the other question I asked was, we had this one, let us equals. We had this apply connect diagnosis, and I asked about this in the Rust forums, because I said, this let us I wanted to do outside here, right here instead, because we have the duplication self player 0, self player 0, self player 0, and it's really not clean code this way. It doesn't look nice, and it's this duplication. The reason it doesn't look nice is because when you have something like this 3 times, anybody coming to this code, something gets the question like, is this supposed to be the same person? Or does this imply this could change in between? Is irrelevant? It adds additional information to the person reading it which is irrelevant to the question we're having. It also makes it harder to maintain. And this is a relatively tame example. When we did the Great Dispatch, we had really ridiculous examples of this. But there's no way to do it that we can find in Rust. And the answer I got from the Rust forum, I'm not entirely satisfied with it. They say restructure your code, but this time we took the effort that most of this code, other than the apply, is already in read-only mode. It's an immutable mode, and we took care of doing all the turns that way, but we actually have to do this apply function, and there's no way for the person calling apply to know what it's going to apply, so I don't have a satisfactory answer here yet on what's the correct Rust way to avoid this duplication. So if you see this duplication come up more often, just understand we don't know how to get rid of it yet. We just don't know. Okay, but let's go back down to the get best turn. Get best turn is done. We're good with that. Now we have scoring. So the scoring is going to have to analyze the state. And the state is going to be, well, how do we analyze the state? And notice we don't have to analyze the turn anymore because we already took care of this. Get best turn is going to apply the turn. And there's some things we haven't applied yet. Like we have expertise, molecules, and stuff. We have a bunch of to-dos we haven't done yet, but we can slowly fill those in. And we're going to get better as we fill them in. But the score now is going to be, how do we score things? And the primary thing we score, and actually I'm going to look mainly at delta score now, so I'm going to ignore how much score I actually have. And actually no, I can't. I have to do it. So the basic scores, let's make the basic score be, and I'll remove the random one first. Let mut score equal, and actually we can just do a whole bunch of things stuck together at once. We're going to do self.player0.health score. That'd be the basic one. Anytime you increase the score, it's better. Increasing the score is better. Plus self. What do we need? We want to say sample score. And that should be enough if we do sample score. It should actually be self.players.0 sample score, but we're going to do with us. It's going to be a little bit of refactoring, or a lot of refactoring when we actually predict the other player's movements, or we don't have to, we might just ignore it. And the scores, this is going to have the avs S64. So what we're going to do is we're going to base the score on the actual health values we get. What are the actual health values? And that'll be the basis of the score, and everything else is going to have to be reduced values of that. So the sample score is going to be, we need to sum up the value of each individual sample. And I'm not going to worry about there is a Rust way to do this, but let's just do it this way for let mut s equal 0 f64, and then we'll return s. Then for self.player0.samples. And can't remember how I do this. I don't remember. I'm going to try and actually use the referencing this time. And what we can do is the simplest way is without any prediction, we're going to say plus equals self.players.0. Actually, we're going to do a let us here again. Let us equal and self.player0. This is the one we said that gets us into trouble, but since we're strictly in immutable mode, that should actually be helpful for us. We shouldn't have this problem right now. Why is this red? Hello? What's the problem with that? So we're going to say sample. I'm going to make this score for clarity. I tend to say this short variable names. I actually don't mind short variable names when they're in a tight, small loop. So sample, and we can do the basic one. Just say, look, if it has health, it's worth more points. Yeah. How do I do that? Well, let's try it. Let's try it the correct way. Let's actually just remove all of this and just sum it up, and we'll do a lambda in here somehow. Well, we're not quite there yet, Reknakas, to the recursion part, but it works basically like in C, except the borrowing becomes a real mess. Is that something's making a really weird noise. I have a bunch of weird stuff in my room, a whole bunch of little devices. I have children's devices in here too, and they make noise on me, so ignore that. We're going to, on this get bash turn, we're going to have to bubble out to very high level, and we're going to duplicate and apply the state and then go deeper down in the recursion so that we don't actually have recursion. We may or may not actually have recursion. We might have to implement it at a higher level. I don't know how far I'll get towards that. The min-maxing, we may not need it yet. Right now we're just doing the maxing part of min-maxing. So we're just maximizing our score. We're doing half of the equation right now. And we're going to see how far that gets us. But definitely there was recursion in, which one recursion in? We did it in Tron. We did recursion in Tron and it worked. It was just normal recursion. That part looked the same, except you had to fight a little bit with borrowing, or a lot with borrowing, but we had the recursion working there. Now we're going to take Johnny the Ripper's idea, and we're actually going to make sum work this way. So us.samples.sum. And I believe there's a sample here. What's the syntax? And ref sample. Sample.health as F64. No method name sum. I'm pretty sure we used sum before, so let's see where sum is. You have to do iter. I'm still uncertain on some of these structures why you sometimes have to convert to iterators first. And this function takes 0 parameters, but 1 parameter was provided. We need some way to sum up a custom value, or map. We need to map it first. Map.sum. I think that might be the right way. Aha! We're getting there. We're getting more into the rusty way. So this should iterate over the samples, and each one we're just going to take the sample health and say, look, this is a good sample. Take it. Gives us more health. But maybe we shouldn't quite do this. We should do it based on the fulfillment. Like how much is... Yeah, I love the Twitch lag. I think we're okay with that, Johnny. We have the iter.sum. But we do well because the lag. It always looks like it's like a good 2-minute lag sometimes for some viewers. It's really weird. The lag is really long because you can see that. So I think iter, we map it and then we sum it, and we don't need to use a let because the return value is actually F64. And since we only use self once, we can simply wrap this up into self.player0 on sample score. We could do it inline up here, but we're just going to isolate it out for clarity. But this is a very bad way to come up with a score. What we should do is we should check the completeness of it. Do we have enough of this? And then value it based on that. So, but not completely, because things without values in them still have to be worth more than something without. So this is where it gets really weird. Because this won't get us very far. The reason why this won't work quite yet is because we have no scoring in here that involves the molecule, so any term that gets us a molecule is not going to be valued here. It's just going to be like weird. And so what can we do? We could do. Do I have a function for this already? We added bookmarking last time. That took a good bit, so we have some bookmarking here. We'll go up to next bookmark. That what? We only have one bookmark. There we go. Player. And what does our sample have? Is sample complete? So this is sample complete. This is what we're going to look at now because we can check it for a player. Do we have the stuff we need to complete it? What we should do instead is make a function that says, how complete are we? And we'll redo that. So function sample completeness, self, sample, and sample. And this is going to return in F64, I guess. As we learned yesterday, this part here where we just return 0 now instead of false is technically incorrect, because if you have expertise and you use the code of the game, which is available online, as Euler Schitzal showed us, you can actually estimate the completeness of something even if you don't have any molecules or if it's not diagnosed, because the expertise for a rank 1 item, there's a maximum for each molecule it could have. So if you had all of those maximums, it would actually be complete even though you have no idea what it is. And I find it really strange the game did that rather than just using randomness, but that's okay. So we're going to have two values here, and I wonder if we can do a pairwise sum. Can you do sums of tuples? It doesn't matter. Let's just do two values. Let mut total equals 0, 32. Let mut have equals 0, I 32. So for each one, we're going to say total plus equals sample.cost I, and have plus equals, how do I want to do this? We need a max in here. Sample.cost I.min self.store plus self.expertise, whichever one's lower. And so that's that. And now we're just going to do have as F64 divided by total as F64. So that says we have that, and we can rewrite is sample complete to do the same thing, and for now we're going to do that. This may be inefficient, but I don't really care at this point. This algorithm is probably more efficient, but oh well. We'll worry about that later. We know it's going to be inefficient. And all we have to do here is say self.sample completeness sample is, yeah. Now the question here is, will this be an exact value? Can we actually say equals 1? Or could it be slightly less than 1? It shouldn't be. Exact value should equal 1. Could be slightly higher than that. So let's just do it that way instead. That should be enough. F64. And so we have this bookmark here as well. So sample completeness. So I'm going to do two things first of all. This initial score, I'm going to put this on a basis of... Actually, no, I don't need a basis yet. Let's just say, so sample health is the sum of sample health divided by 2, or actually times 0.5 F64. So the total health of the sample is worth something, and we're going to have to adjust this value later, plus the sample.health as F64 times times self.players.0.sample completeness and sample. So we're just assigning extra score to it. We're saying for every sample, its health, half of the health, we can consider its current estimated score, and the sample health times the completeness is actually added to that score as well, because that gives added score. And this actually exceeds the up score up here, which is not so good. But that's okay. And I have a feel, I'm going to see what happens. That this should be actually enough to make our character do something. Because this is a value turns, except I'm worried about one thing. I'm worried about the go-to. We haven't valued where we are yet. And so we might not actually move to the correct location yet. But let's see what happens. We might move just by randomness. Otherwise, I don't know what happens. And what one could do here, and well, we'll preload this as well. RNG.genRange 0, Does GenRange accept floating points? Probably not, because it doesn't let you overload, so... And GenRange. Oh, it actually apparently does. So GenRange, we can accept a 0 F64, and we're going to do a 0.1 F64, and just add this to the score. What this does is that for all the stuff that has the same value, it just sort of randomizes it. So you never get stuck, and if any other player is actually attempting to analyze you, you might do random things. But let's see if this actually works. Let's see if this actually does something. Can I make this smaller? No. And I don't appear to be picking up any samples. And I should have picked one up there, which means we're not valuing something correctly. We're still doing something at random. Did this actually get my newest code? Something's weird here. It feels like I never actually got the code, because we should have done at least something. We should have picked up a sample. Score is here. Okay, I know another thing we should do, and we have to include the rank, because when things have no value, it won't have a rank. So I'm going to increase the value of this here first, times 10 F64. So real score is worth lots, and a sample score. So we're going to make everything base 10, rather than shifting all the fractions down, or maybe that's not so good. I don't know. We'll worry about that a little bit later. And so if the sample has health, if the sample doesn't have health, if sample health doesn't have health, then we're going to return, get rid of the if. Then we'll say sample.rank times, or we'll just give it sample.rank times 10 as F64. Else we'll do this calculation. So if we don't have the health yet, we'll give it something. I wonder if that's enough. I thought the last one would be enough, but obviously not. He is moving around, so I was worried that moving around, but once we're at a station, we should definitely be valuing stuff at the station. Oh, we picked up stuff, so actually we did something this time. And why did we go over there? Okay, so the go-to isn't working. So now we're filling stuff up. And this is the completeness thing. We're going to fill up our completeness because it gives us points. And we didn't give them away. Oh, that was kind of stupid. What do we do? Okay, so he's not giving stuff to the laboratory. We have full things, but... Right, so why do we not give anything to the laboratory? Because giving stuff to the laboratory should be giving us lots of points, unless it's not complete yet. Oh, crap, yeah. So he's stuck because he doesn't know how to fulfill these samples. So we're stuck here, and alright, so this sample thing we have to do, we have to have another condition. Can we fulfill this? Could we possibly fulfill this? And this gets a little bit weird, and how do we want to score this? So basically we need a score of self.player0 can fulfill and sample. If we can't fulfill a sample, we're actually going to return a negative score. This sample's bad. Whatever we do, don't take this thing. We have a bad sample. We can't fulfill this thing. We just have to define what can fulfill means, because if it's unidentified, then we're not certain here. Okay. So what do we have? We have a player up here. We're going to have to do can fulfill and self sample and sample. It's a bool. And the question could be, if sample.is diagnosed, we're going to just do a hard coding here. Return sample.rank equals 1. Now this is going to cause us to only ever pick up 1 samples in the game, but let's look at that later. I just want to see that I want to get something working first, and can fulfill basically is the same loop down here. Or what is it? It's okay, we're going to have a similar loop. So we're going to have to work on that. So we can ignore this first of all. Let mut total equals 0, I32. And this is where it's going to get a little bit weird, because you can never get rid of molecules. So this is going to be remain. How much do we have remaining cost? Okay, now I'm thinking aloud. We're going to take the remaining cost and see if we have enough space left to fulfill it. If we don't have enough space left to fulfill it, then we can't fulfill it. And there's a lot of tweaking we can do here, because you can have 2 or 3 samples, and that may be okay. The -1 could mean it could still be worth something, a potential value was worth a lot less, and grab something else. Okay, whatever. So remain plus equals the 0.max of sample cost I minus self.store I minus self.expertise I. So this is how much we have remaining to fill it, and we have to say if and then return value is return remain is less than max store. As long as we have store space left for this, except Great. Let mut remain store equals max store. Let's do that. Remain store minus equals self.store I. So we have this storage used up, we have this remain store, so as long as remain is less than remain store, then we can actually analyze the sample. And we have it down here, can fulfill. If we can't fulfill it, return -1. That's a kind of questionable value. But let's see if it actually makes us do something. That's the main thing. I just want to verify that the scoring is actually working. Last time it looked better than the first time. And if we can ever get any points, it verifies that we actually do something correct. So we pick up samples, we go like an idiot over there. And that's why I said our walking is not so good to begin with. We don't have a way to score the movements. If we get there, we'll do the right thing. Right? Once we're there, we do the right thing. But, oh. Okay, so we couldn't fulfill any of them. We just threw them all away. Which rank is it picking up? It's still picking up rank 3. That's why it's getting. That's why it's wrong. Why is it picking up rank 3 still? Because can fulfill, we said if the sample is not diagnosed, we return sample.rank equals 1. So why on earth would we be picking up something that isn't rank 1? It should throw it away. The moves that consider that should just be thrown away because it has a negative value compared to the other ranks. And Oh no, I know why. No. Huh? It's gonna be hard to debug now. So down here, I was thinking originally that, well, because the other ones might still have score, but if they're all unanalyzed, we have this big negative. The things, as long as we can't fulfill them, we get a -1. So we're not going to accidentally take the score of one we can't fulfill. But the question is, where on earth is that score coming from then? I'm confused as to this because we threw them away as well. Why did we do that? I think there's something wrong in the canvas. The sample is diagnosed. The sample is not diagnosed. I think that's correct. We use diagnosed in many places. We return sample rank equals 1, because then we can fulfill it. Otherwise, we check how many molecules it has. But we never get to... We must have gotten to this point at least once. And we threw them all away. So we analyzed them and then we tossed them all away. And that was because they were rank 3. But why on earth did we pick up rank 3 items? That's the question. Why did we pick up rank 3 items? Let's try the apply connect samples. Did I do something wrong here? Connect samples. We push a sample from the rank turn ID. That looks correct. So what is from rank? Default health equals 0. It's unanalyzed, and we have a rank, and everything's 0, so that looks correct. Turn and enumerate samples. What are we doing here? Enumerate samples. Turn connect 1 to... So I'm going to do the rough thing first and just disable that so we can debug that later. And we have to figure out why it's taking this 3 ones, because the value is kind of wrong there. It's like getting really slow today, this evaluation. Okay, again, we have to work on this, like, we have to work on the scoring so he actually goes to the right place. Once he's there, he'll do the right thing. But he's going to bounce around at random. He should do the right thing here now. And we have to wait for him to get here, and now he should do the right thing and fill at least one of them up. Now we have to wait for him to go to the right place, and he should toss one in. So we actually get health now. Okay, so we bounce around at random, but we actually do something useful when we get there, but only for rank 1. So this is at least showing the scoring is somewhat working, and we're going to keep collecting molecules here because it's worth higher score, and then it's random. We're going to lose to him because, again, we're about... And we grab some. That's interesting. We grab some from the cloud. So we can obviously do things from the cloud. And we walk around like idiots still. That's totally fine. And that's the next thing we have to fix, is stop walking around like idiots. And that's not so hard in scoring, I think. Basically, we just have to give a score to the value of his modules. And you notice a little randomness down there. I picked up molecules even though I didn't need them. Alright, so we lose. But I'm curious as to how far this gets us. So let's submit this and see how far it gets us. I'm just going to let that run, and I'm going to quickly grab some more water and I'll be right back. Alright, so how are we doing here? Are we doing okay? We're winning a lot, which is... and we're losing a few. We lost the early ones. We're doing better over here. Curious. Curious how we're doing that. We have a lot of stuff left to go up, obviously, and... where were we? Evening. Forgot where were we? Come on. Lost battles. 48. We're not at 40. They're at 50. We are in the process of going up. So let's just let that run and see where we get to. And I wish I could throw that somewhere else in the screen, but we'll see what happens there. And... just want to check my visual. My chat window doesn't fill up my area correctly. There we go. There we go. Should be better. Wonderful. Now let's get rid of this again. So our rank goes up there, and we have to figure out this here. We have a big to-do here. To-do. Why are these selected? This has to do with the scoring, and I've forgotten where our scoring is. And we're going to do sample to, and I'm going to call this not score sample, but score sample. Score sample. Consistency in naming. Score where. This is where we are, like the location. And the location is automatically the target one, even if we're not there yet. And that'll be okay. And this scoring is going to be a little bit hard here and so basically if we have an incomplete sample, or we don't have any samples. Alright, so let's do this. Let's do a match self.players.0. Where? I find this lookup is actually working worse now than when we actually had, when we didn't have RLS target. Anywhere else probably shouldn't be good. Score's not good anywhere else, and that's probably like an undisclosed location. Module samples, and these values are going to be really questionable how we do that. So samples basically is This might actually be worth, -1 should be worse than left, but we shouldn't actually get these ones anyways. And this has samples has a high value if we don't have samples in the hand. So we're going to do self max samples. Do we have a max samples? Max samples, yes. Max samples minus self.players0.samples.size. And let's just do a let us again. Let us equal and self.players0. So this gets difficult. Us.samples.size. So the difference between the max and us, and let's just say this is worth 10. Now, if you see all these scoring, one of the purposes of scoring here is that if you were doing a training system, and if I get this correctly, I haven't done them too often, or I've only done them in tests, all of these constants here, you could use like, you would put them in a training system and you would put them like in a neural network and let it figure out the best values for these. And we're just going to have to eyeball it. We have no mechanism to actually do that because we can't continue to compete with the other people. But if you were offline and you had multiple robots, you could actually do that. Or we could play against ourselves. That might be unfair, but let's just say this. This has to be as F64 times 10 F64. I get tired of typing F64. Module laboratory. And here we're going to do a completeness thing again. This score sample here. Going to the laboratory is really good if we have completed samples. So we have us.samples.editor.map again. And we have a bunch of redundancy here now. And we might want to get rid of this. We're going to say, wow, this is really going to be the exact redundancy. Now, a laboratory is only valuable if they're complete. Is complete. Yeah, since we installed RLS, the look-ahead has actually gotten worse. Like, if you don't have anything correct, it doesn't do the look-ahead for you, so it's actually become even worse. If sample is complete, then we return sample.health. It's worth a lot to be there then. Else, nothing. It's no value to be there. And we can't return a negative because there might be something there. Okay, and what is it getting mad at me? No field size. Samples, no size. Length, fine, that's up there. This is going to be a sum. Sample dot something. Tell me what. Give me a lookup now. Is sample complete? That's what it is. Is sample complete? So laboratories of value, and otherwise, what is of value? Diagnosis is of value when we don't have any analyzed samples. Or we have, again, this is going to be a us.samples.editor.map sample .sum, and that underlying is so annoying. Just give me a chance to think before you launch the errors up. Sample.isDiagnosed. If the sample is not diagnosed, then we're just going to give this a fixed value of sample.rank as F64, so it's a valuable to get it diagnosed. We don't know how valuable it is to get it diagnosed yet. We'll just say this and see if that helps us any. Else, if, what do I say? If we can't fulfill it, if us.can fulfill it, if we can't fulfill the sample, then there's a really big value to coming here, and I don't know what this value should be. The reason is because if we can't fulfill it, we want to discard it, and this is the only place we can do it. We want to discard. And that's why it has a really high value, because coming here when we have a sample, we want to get rid of it. But we have to balance this here, because if we don't have enough samples yet, the moment we pull up one we can't fulfill, we're just going to go and dump it away rather than grabbing other ones. Okay. So I think that's okay. Else, we have to have a final else, 0f64. Otherwise, there's no value going. If we have a diagnosed sample and we can fulfill it, there's no value in taking that to diagnosis. So there's no value. But we have a plus here, and this is the same as the first one. If we're missing some samples, we go here. Now, ideally, we'd actually do it a little bit more extensive here. That we'd actually look at the sample values in the cloud and decide, hey, look, there should be clouds here. So we're actually going to go say, grabbing new samples is better going to cloud, but we'll have to come back later and say, well, let's look at the ones in the cloud. What value do they have to us, and analyze them again. And we're going to have to redo this a lot. So this scoring is super complex, and we have one module missing. Module molecules. So molecules is really, it's a sum of sample completeness, basically. We just do this, sample dot completeness. No, us dot sample completeness and sample. Actually, 1 minus, so the less complete they are, the more they're worth. 1f64 minus. And I'm just wondering, do we have to multiply this by anything? Probably times the sample health. Yeah. That just... it's kind of bugging me too in Rust. The continuous casting all the time. I mean, i32 works fine on an F64. There's no lossy conversion there in i32, and it has to do with their typing system. They just can't do it, I think. And this has to be like this. So that covers the modules. This should get us going to the modules. And where is that? Did I have an error? This has to be us dot is sample complete and sample. That's why it's not working there. And sample. What's it whining about now? F64 as F64. Now where's my problem? It's a comma there. Shouldn't be there as times. Cannot analyze, cannot resolve sim of x64. So what's wrong here? Type annotations required. Why does it not, why can't it analyze that? I don't get why it can't figure out that type. And I actually don't know how to give a type. Okay, this is a Rust thing. I don't know. Each case of this if here, this map, this returns a 64, this returns a 64, this returns a 0f64. They all return f64, so I don't know why the result isn't there. What if I take off this bit? So it doesn't like with the plus. That's really weird, because this plus is as 64. Well, that's kind of annoying. S plus. I'm going to put a to-do here. Rust question. Couldn't do sum plus . Okay. So now we valued all the locations. So maybe we actually walk somewhere to the right list now. Let's see if that actually works. We actually go to the right place. And this is a loading bar at the top, but so we went to the first place correctly. Then we went wrong. What are we doing? So something's wrong with evaluation. It's valuing missing samples way too much. It's going to the laboratories. There's something wrong with our laboratory cost. Definitely something wrong with the laboratory cost. Laboratory says sample complete sum. Sample should, that should be 0. The cost here should be 0. But it's not causing enough value. Because the actual values here, the actual values of the samples, the estimated values are way too high, and this isn't balancing it off. The 0 isn't detracting from that, so the actual sample values. But everywhere else should be worth more. That's what kills me, is that because the other scores are constant. These scores are all constant. Well, except the generate range there, except the default one. Let's actually get rid of the randomness for now. Maybe our values aren't big enough. So we had the score samples. What are they worth? And the samples laboratory means if we're missing anything, it's worth a lot. But maybe it shouldn't be worth that much. You notice we went back too often. So let's just say times 1 for now. If we're at the laboratory, has 0 cost. If we have nothing that's going to be completed, it should have 0 cost. Okay. Diagnosis is, if we have a diagnosis 1, then we take its, if it's not diagnosed, we take its rank and say, look, it's worth that much to be there. If we can't fulfill it, then it's really valuable to be there, so we can get rid of it. So we definitely can go there with something unfulfilled. That might be too high of a value. Otherwise, it has 0 again. I'm not liking these zeros. Plus, if we're missing any samples, there's a value to be there as well. We have to adjust that down to, we're going to say 0.5 because this other one is 1. So we prefer to get them from the samples place. And if we're at the molecules, fulfilling things should be worth quite a bit. Okay, but these things should all be worth less than actually the actions here. So we might have to adjust the values a lot more up here. Well, let's see if they make a big difference. No. So our actual simple thing didn't get as much higher in the ranks than total randomness because we're not doing much better than random still. If we can at least recreate our previous score. So I grabbed some stuff and then I got stuck there. Which means the reason I'm stuck there is because it must have been the random score dominating before, and this makes no sense that he's stuck there. And sample where is not giving us values. Sample where, well, time to do some debugging. let the base value equal, well, actually score value equal, we'll just do it this way. Let sample equal self.score sample. Let where equal self.score where. And so this range was to ensure we didn't get stuck. So we're actually going to stick it, and we're going to stick something on it again. Let r equal this. And it's sc plus sample plus where. And we're just going to ignore the r for now. We're going to do an ePrint line. And this is going to be ridiculous because we have lots and lots of things here. We're evaluating lots of turns, so it's going to be really big. We might not be able to actually debug it. We've had that issue before. And where is the... Just call it WH then if it doesn't like where. And where's the one that's causing us trouble? Why am I getting stuck at where? So where, this last one, is only ever giving us 0 values. That's a bit funny. One of the wheres gives -3, and that's the probably the... So how can where give us minus values? Maybe our target is wrong. Let's match us.target. Something like this. Self.player0.target. Maybe we're not applying the target correctly. And that would explain it. If we're not applying the target correctly, no, we're applying the target correctly. So every single one of these we're getting a minus for molecules. Does that make sense? No, it doesn't make sense. It doesn't make sense that we get a minus for molecules. That's really weird because we don't return a negative here. Sample completeness is between 0 and 1. 1 minus it. Unless sample completeness can somehow be... I mean, that's not what our problem is. Diagnosed. Total sample cost. And they have a sample cost I minimum. Okay, that might be it. I thought they had a... Oh, that's right. I thought they had 0. They have 1. Thanks, Nkoy. That's the issue there. So that's why it was negative. Okay, but why are the other ones returning 0? So sample is 0. Diagnosis should not return 0. For each sample here, if it's not diagnosed, we take its rank times F64. So we should have at least got a 3 there. So the diagnosis thing should have a value of 3. Unless there's no rank, but that makes no sense. The rank, we have a rank. Let's see what we have stuck in there then. It is diagnosed, and it's rank. It has a 0 rank. Where's the 0 rank coming from? Rank 1, 2, or 3? Are we not reading in the rank somehow? When we read the turn, have we never actually read in the rank? It's possible. Read player's return. We never read the rank in. That would explain why it's random, why it's 0. Sample.rank. We'll have to figure out the expertise gain. So we'll get the rank. That would explain that issue there. Let's go and test it out. Alright, we went to the right place. That's good. Hey, look, we're going to the right place. We're not getting any molecules. But we went to the right place. That's all that matters, doesn't it? We're very happy we went to the right place up to there. Now, at the molecules thing, yeah, it's because collecting molecules doesn't improve our score. That's a bit weird. Connect molecules definitely increases our store, so it should have given us more value. Let's get rid of, let's look at the ePrint lines again. What are we getting there? We have samples are, so the base score, we don't have a base score. The sample has a value, and some of them have more value. We should probably say what that is. Can we say, oh, we don't know what the turn was, though. Let's do that debugging. How can we actually debug the turn? Something like this, or no, it's a hash. No, this. Turns I. We have a warning of some kind. It's fine. Thinking. We go down here, and now what are we doing? We don't collect anything. So let's pause this. Go to. They're not worth very much. Connect type, yes. This gives us value, so we have value for connecting. And value, oh god. But we have a higher value for going to the molecules, and that's the problem. So, where we shouldn't have iterated that. We shouldn't even have that turn up for consideration. Because if we're already at molecules, it doesn't make sense to go there. But that's where it's showing at, destination molecules. No. She said that doesn't make sense. No, that should be fine. Connect type diagnosis. Connect type 3, connect type, they're worth more. Why is he not connecting them then? Does weight. Weight's worth 1.5. So small. Let me add up the scores. Let's change that ePrint line. ePrint line. I'm going to put the score here. Something's wrong with that. It looks like we have a higher score for what we want to do, but it's not actually doing it. Alright, so go there, collect stuff, that's good. Go over here, collect stuff, that's good. Alright, now we're there. Now what do we do? 4.5, weight. 4.5 is worth a lot. We have something here that matches it. Okay, so we have a break here. We have 4.5 for weighting. I mean, weighting is never a good option. And I wonder if we just take weighting out. No, I'd like to keep weighting in because there should be a way that we actually have more value. And I think it's because of when we're scoring that location on molecules, we have a... So this one says, as we complete things, it's worth less and less to go to molecules, but the actual samples are worth more and more at the molecules. And if the health happens to be 1, then this value here is the inverse of this value here, meaning weight's going to be valued exactly the same. So having molecules has to be worth slightly more. No, wait, this is just weird. Because I can't put it here, because that'll reduce the weight as well. So we have the thing. Having is good. Collecting, I think, has to be better. I'm thinking about this. How do we logically do it? Well, how can we make collecting be better? Now, either way they have it should be good. Oh, how do we do that? And how do I break that dichotomy there? Just say, look, having one has to be better than... No, having one has to be better. So just being here can't be worth as much as having one. So this is a potential value here. This is not an actual value. Real value has to be worth more than a potential value. So we're going to have to fine-tune those a lot. Again, if we put that all in a neural network, just let it fine-tune it for us. Let's see if that worked. Analyze, analyze, analyze. Oh, we're collecting stuff this time. Great. We don't collect them all. Kind of annoying. So we're just fulfilling one at a time, which is really weird. So this is where our scoring is coming in. We're not fulfilling enough at a time, because there has to be a negative value there, and that has to do with the ETA. We say there's no time involved in getting to the other place, which is kind of the issue. So having molecules has to be worth more somehow, because we really want to fulfill more stuff there. We really want to get more molecules before we go over, because it's such a huge cost to go over there. And that's just where the per turn stuff has to come from somehow. And I wonder if maybe we're not overvaluing putting stuff in the laboratory. Because when we put stuff in the laboratory, it means, hey, look, this is really, really valuable. Yeah, but definitely, Nuggets is definitely improvement. Thank you. We are improving. We get points now. Before I submit again, let's. We can actually undervalue the laboratory. The reason we can undervalue the laboratory is because if we have nothing else to do, all the other moves are going to give us a 0 score, so the laboratory we can actually give a little lower. What is that? I'll might as well look at it, but no, let's look at this later. I'm tempted. No, I want to figure this out my own first of all. Let's look back at that. I'm going to actually bookmark that in case we get back there. So if we don't have a better algorithm by Sunday, which will be the last time we work on this, we'll just look through here and see what he does. But I really want to figure this one out my own for now. And so giving stuff up to the laboratory shouldn't actually be worth that much. It frees up potential value, but actually collecting new things has to be worth more. Okay, how do we do that? I don't know. A lot of this stuff is new to me. I've never actually really done AI before I started doing Rust, so we're doing Rust and AI at the same time. I've never done a lot of this stuff. So we're going to undervalue this so that collecting new molecules will be worth more. And see if that helps us collect more at once. Because more at once is really important. So we go fill those things up. We do exactly the same thing as Dr. Quinn. We fill more. We should fill them. No, we didn't fill enough up. No. Supposed to fill more up first. We're not filling up enough. Potential score has to be worth more somehow. So make it worth even less. Alright, here we go. It's going to work. I think it's going to work. I'm not going to promise that. I hope it's going to work. I mean, let's grab stuff. Grab more this time. More, you stupid little bot. Yeah, we're grabbing a lot this time. Great. And we didn't fill it up, though. Oh, it's because of the timing, I bet. I bet we have enough to fill them all up. But because I have fewer samples, it's valuing getting a sample at even higher. So this is where the ETA is going to come in. If we're at the laboratory and have samples, it has to be worth quite a bit. But if we're at the molecules and need molecules, that has to be worth more. So this is where our scoring is getting a little bit weird. We're actually getting worse this time. Are there things with 0 health? Because we collected like the tiny, tiny amount. We filled up 2 that time, surprisingly. We got stuck there. That was bad. Okay, so what have we done wrong? Getting rid of samples has to be worth quite a bit. So I'm not convinced. This actually has to be worth that score, and it has to be worth a lot. Or not. Because we have the score. Apply score. Apply connect laboratory. Yes, that's it. We're going to have to remove these molecules as well. So we have this score, and this score already counts for this, so we don't have to account for the score at the laboratory. Being at the laboratory, yeah, because we don't do 2 steps. This is the really weird part. We don't calculate 2 steps, so somehow we have to do that. But here we actually have to remove the molecules here. So let's actually do that for in 0.num molecules. That might make a difference here as well. us.store minus equals 0.max US samples index.cost minus us.expertise I. So remove the molecules. And what's the problem now? Oh yeah, here's store I. So this gets rid of the molecules, and that's going to reduce the cost. As submitting is going to reduce the cost. And I'm still not convinced it's enough. Let's check it out. That should make a big enough difference that we could see him do something different. I'm still kind of just happy he's doing anything. Kind of validates that there is logic in this approach. So that's good so far. Good. Collect a bunch of stuff. We didn't turn over more than 1, though. Just disappointing. It may not be the bad thing. We don't know for sure if that's wrong. We did give over 2 that time. Oh, I know what the issue is. Why we only give over 1 is because we never actually get enough molecules to fill more than 1. Right? Because I calculate them independently. So I do each one independently, and so I only ever have enough molecules to fill 1 of them. Aha. That's a bit weird. How am I going to score that? Why do you go way over there? So it was actually pretty good there. And we have another one we could fill. You notice how sometimes we skip the molecules, so we're using our expertise now, but we should actually be picking up higher ranked items now, and we got to figure out how we do that. And we had to figure out a way to load up our molecules a bit more. Again, we have that phone in my background. So we got more points that time. So let's see if this more points gets us any further. We have actual more points, and we're doing things that almost seem quasi-intelligent. And the problem with the scoring approach is until you get the numbers quite right, it will look like you're doing dumb things compared to what you could just hand code in an expert system. Because the expert system, you could just say, look, do this, then this, fill up this. And so our scoring is going to have to be, first off, we have to figure out how to get more ranks. So we only take rank 1 so far. And again, we can always tweak the turns. We have 2 places to tweak. We can tweak the turns to take. If we know which ones are okay, we can tweak that, and then we can just don't have to score them. But what we want is molecules. We want to grab more molecules here. Getting molecules has to be valuable. And his approach here is it definitely looks like grabbing molecules over grabbing more samples is certainly helpful. We're uncertain about that. We look to be doing a little bit better, though. Not a lot. Okay, what do we do now, then? How do we do scoring now? At the molecules thing, molecules have to be worth more somehow. Score molecules. Well, it's the score samples here is the issue. We have an issue with score sample that this completeness here, we have to consider the previous completeness, whatever things have been used up. Now, how can I do this in an efficient fashion? So what I'm saying is that if one of these is marked as complete, whatever samples we use can't be used to calculate the completeness of the other ones. That becomes very difficult. How do we fill up more than one at a time? We will fill them up until they're all complete. But only partially because we only have the molecules once though. So, I'm thinking. What's he going to do? We're not making it much further. 49. Now, how do we do that? Somebody has clever ideas would be good, but I'm trying to think how we can do that. We want to have... Would simply increasing the ranking improve it? Where was that to do? There it was. Let's see if that makes a difference now. We got stuck on that before, but maybe we fixed something that makes that more worthwhile now. Because it's vital that we can select higher rank ones. Rank 3. We could actually complete one of these though, so why is he not going to complete it? He's stuck again. Because giving up samples, but he shouldn't get stuck. How on earth can it be? Weighting's worth a lot. Okay, because weighting here gives us 218, whereas diagnosis, connecting to get rid of the module, gives us 198. It's a higher value for that. Maybe what we should do, and instead of giving value for giving away the ranked ones, we should actually have negative value for things we can't complete. So sample complete can fulfill. If a sample can't be fulfilled, let's give it minus 100. That's bad. Unfulfillable samples are bad. And that'll actually force us to give them up. So that makes going to a diagnosis really helpful. It's really strong because giving them up. And this should give the balance here to actually give them away. You could actually even make this higher because giving them up is like the highest thing you do. But you don't want to balance it too much. Prefer to just stick these all a neural network and let it figure out on its own. But we'd have to like have an offline thing to evaluate it then. So we got up to 40 with the algorithm before, so we did actually do better. So we keep one, but we stuck again. We're waiting, which is bad. Really bad. Why are we waiting now? Because weight is still worth 54. Going to samples isn't worth enough. So samples, and I think we have this two thing that I don't go two steps in the future, because when I go to samples, all it does is being there, and what we really want to score is getting stuff from there. And this is where it gets really weird. If I actually want to do two steps in the future after I wait and go down further, and so the scoring is getting really hard because I'm having to predict what to do, and it's duplicating a lot of the code. Connect. So none of them. Maybe I should just get rid of waiting. Force them to do something. So we never stalemates. We could do that. Let's try that first. Let's let him never do something, because we know the game already ignores if you do something while moving. So let's just say he never does anything. He always has to do something, and I think that's a fair rule. I mean, it's not what I really wanted. I thought the scoring should be enough. The scoring should have been enough for him to realize to do something. And so there, he doesn't do anything. He collects more. We still have that problem that he's taking high-ranked ones, and I have to figure out why he's doing high-ranked ones. Because, right, he's just going to keep collecting these molecules like an idiot. It's this one here. What does it expect? 7C, and there's no C there, so he could be waiting forever. And this is actually, our scoring should take this into account. If it can't be completed on the board, it's not worth very much either, and that's something we're not considering now either. But the main thing I'm worried about is, why does he keep taking rank 3 things? Yeah, because we definitely have to value the score here, because C never comes back. That's very curious that C never comes back. Alright, so the first thing we have to do is figure out why does he pull rank 3 ones there? Okay, so we're here and we're at the diagnosis. We want to say go to. We want to connect. Oh, because I said the rank ones are higher. Yeah. But that has to do with the completeness. So the ranked higher ones are just worth higher, so it makes more sense to connect them. But they have a higher chance of not being completable. Wow. How do I do that? I don't want a hard code rank. I want to get the scoring correct. And Koyan, you're indicating something. Can there never be more than 5 at a play at a time? Because I noticed this from the game too, it's limited to 5. Is there something in the rules saying that about a magic number 5? Total molecules for rank 7. So we could actually take rank 2, but alright, so we'll have to do some hard coding magic here. Not hard coding, but fine. I'm just going to do it. Where did I put it? Enumerate samples. I'd still like to push all 3 and just kind of give them a random value though instead. So we do the ranking there. So we have to say the samples are, when we score the samples, score sample, it should just be score samples. Because I keep searching for it, so that must be the name. Score samples. I'm curious as to what Nkoyan says though about that 5. And I noticed the game, there's a limited number of molecules in play at a time. I'm just wondering if you have a maximum of 5. So is there a maximum of 5, or is it based at the beginning of the game? That is what's available at the beginning of the game, is that like the maximum available, or can it go higher than that? Because that would make a huge change in the scoring, that basically my completeness would have to be based on the fact that can fulfill. So this can fulfill function would have to say, if it's above a certain limit, it just can't be fulfilled at all. Okay, in any case though, if it can't be fulfilled, if it's... This bit here is what's to blame right now. And we should base this on the expertise, the rank. How do we do this? Yeah, no, 5. If 5 is the actual max in play, then I can definitely work with that, and it'll come here, fulfill. Because that'll really change that fulfill. If you ever need more than 5, it's worthless as well. And so this rank here, at the sample health, we're scoring the samples. How much is something ranked 10? We don't have the basis right now. You get one each. Okay, so 2 people can pick at the same time. So it is some. All right. unless simul-pick. I'll see if I can remember that note later. So the first thing to rank here is, how do we value this rank? This rank has to be based on our expertise. And so the values there are, if we have, let's go back to this now. I showed it here somewhere what the values are. We have, so rank 1 we can always do, and we can just basically hard code this that okay, yeah, that's what I got. I'm guessing that as well, Petrosol, but thanks for confirming that. So we have to take our current rank. We need some scoring to say, what is our current actual expertise rank here? So let's go back here, get rid of some of these, and go to the player. We're going to make a function that says, what is our rank, average rank, I guess. Average expertise. And self. It's going to be a big F64 as well. And this will be self.expertise.iter.sum q as F64. No, this has to be map. This is actually great long. iter.map.q is 64. Why is it not like that? I don't care. Because it has to be like this. I don't know what that is. Second divided by molecule types. Yeah, this look ahead, I actually preferred it better without RLS, because RLS, what happens is if you can't compile, it appears that you turn off look ahead entirely, whereas before at least it had the intelligent lookup of values. But what is this problem here? And we're going to map an and. This is really weird. I don't understand this one either. It's the same thing again. To do Rust, why not? And then we'll just split it off and do it the other way. So average expertise, we have that. And now we're going to hard code it. If sample.rank we could take our chance. If sample.rank is greater than self.player0 average expertise, we get 0. This should probably be max expertise or min expertise for safety reasons. F64. Let's make another one called min expertise. Rust, wait to build. Excellent. Doesn't show up. Rust, wait to build. Let's at least put it to... This is the other thing that bugs me in computers, that why is milliseconds the default? Why don't we use like normal things like seconds, like 0.5 and stuff instead? Like, there is an SI unit for this. So we'll give it 2,000 because we usually think enough. I talk enough here that I don't need that fast of feedback. Min expertise. Is there a min? I hope there's a min. And this is actually an I-32. Mismatched types. Why? I'm pretty sure expertise is an I-32. Expertise is an I-32. Why on earth would this need to unwrap? Come on. Okay, the wait to build is kind of annoying as well. Is there some way I can just say build on save? I want build on save. There it is, build on save. That'll make me happier, I think. What is the type here? I want to know what the type is. What is the type? What does the min function return? Lost min. Iterator min. There must be an iterator min by min. Let's go to min by first. Option self item. All right, where was I? Where'd it go? Well, yeah. It's an I-32. And the type is self-item. So I don't know why it's not working. What type is this whole thing? How do I tell which type this is returning? Unwrap is not helping T. I don't have a type T. Let me check something. I land at q equals self.expertise dot editor dot min, and this is an option I-32. Q dot unwrap. 96. Well, what's the problem? Does it not need an iterator? Oh yeah, I keep forgetting to check that. Expected I-32 found and I-32. Ground type and I-32. Dereference what is the question? Whatever, let's just go with this. To do rust. Alright, so min expertise, let's go back to there. Min expertise. If the rank is greater than our min expertise, -1, because rank starts at 1, then we just say 0, otherwise the rank stuff is worth more. That should help us avoid collecting crap. Alright, where are we? Play my code. What do we do now? Come on, load, load. That little tiny line at the top saying our servers are overloaded. Wait for it. Did I get rank 1s this time? I did. I got lower ranked ones. I'm still only going to fill up one at a time. Go get another one. So he fills up lots at once. And that makes sense. Filling them up has to be worth more than the samples itself, because we're taking this long circuitous route that's costing us too much time. And I don't have time involved in there, so we can kind of fake it first of all and just say grabbing new ones are worth more. Because we're falling behind. He just goes back and forth a bit here, so back and forth. And he collects all his samples, fills them up, and we waste all his time. And we just fall behind. So, what's the correct way to fix that would probably be the timing. So the one thing we could do, we don't have the ETA in there very well though, because we're not actually calculating the ETA. So it's always going to be divided by 1, so I can't really consider it. So somehow we have to say that collecting more samples isn't as good as it sounds. So a sample can't be worth as much. An undiagnosed sample can't be worth that much. Just make it worth 1 and see what happens. Just, they're not worth as much. So we got a bit more points that time, but that could just be the randomness of the level. It's weird pausing every time I go do that. Oh great, now we only grab one of the damn things. Come on! This type of fine-tuning is what a neural network's actually really good at, is actually fine-tuning small values to find them. And in some strange reason we got another one there. Because the logic is, if you're here, you might as well just collect 3 samples. And we can do that by sticking the ETA in. ETA is, yeah, let's just stick an ETA in and at least it'll collect 3 of them. So to make it not so much, we can do this. We can say let ETA equal self.player0.ETA as F64. And we can minus the ETA. So ETA is always bad. Going anywhere is worth less than just doing something. But it might not be enough to dissuade him from doing stuff. Did I collect more? I collected 2. That's weird. Threw one away. Why would I throw one away? Are there like rank 1 ones that I couldn't finish somehow? So at least we collect 3 again, but we don't have this going back and forth here, which is very good. We have so we actually picked up some of his from here, which is interesting. And we went back, so there is some situations in which we go back here. That's very curious. We're actually doing something different this time. Only picked up 2, oddly. And we actually do go back in some cases. We're not going to beat him, though. He's still slightly ahead of us. The picking up 2 is kind of stupid. So we can say times 2 F64 make moving more costly and make the ranks worth slightly more, and that would make them do a little bit more, I think. So we do pick up 3 now and throw them all away like an idiot. Oh God, what are we doing? Why did he throw it away? That's silly. What on earth is he doing? Go to is minus. Fine, fine. Crap. Because throwing it away... So when they're worth 1, it's not enough. Oh, come on, this balancing of the score is going to be really annoying. They've got to be worth more than that, so throwing them away is not really worthwhile. Because I'm only looking 1 turn in the future, and this is kind of causing the problem here, is that if I actually set up my recursion, and I was hoping I wouldn't have to do that, if I set up my recursion to go multiple steps, but I don't think we have enough time, like physical time on the thing, I mean 50 milliseconds to do that in the current form. And so what's happening is he's sitting here, and going here would be worthwhile, except I minus the ETA value, and it's not worth enough to account for that. And the ETA value was put in to make sure he collects multiple things here. But if I simply make them worth more... Wow, is this going to be silly? I hope at least you're enjoying watching him walk around like that. So he collected 3s. He's just going to throw them away. Oh, he actually goes further. That's a good sign. We don't go back there, though. We still have to figure that one out. We threw one away and... Oh, no, we're stuck again. Damn it! Why is he doing that? Stupid evening rust pot. I have a feeling that negative values are bad. We probably shouldn't do them because we might get into loops. So let's find all the negatives and never do them. Instead of doing that, we might say 10 minus, but that's going to do the same thing. It's worth more to wait than to get points. Well, we can do this. The ETA Johnny, this is entirely round-based. You don't implicitly have an advantage being faster, but what'll happen is if we start going deeper into the stack of prediction, having faster code will help because it means we can evaluate more. Because right now I'm just going one level deep, and that's where some of my problems are coming from. But if you can go faster, you can go deeper and deeper levels, and that'll give you an advantage. So the further you can look in the future, the faster you'll go. But and that's the advantage of it. There's no inherent advantage of just making the decision faster. That would be entirely unfair. Okay, it's still unfair to the languages. So at this point now, we have no advantage to go faster. So we have a base score, and then we have a future score. And what we can do is take this future score and divide it by the ETA plus 1. And F64. So it reduces the value of the score based on how far away it is, but it never actually gets rid of it. So it's not a minus, it just reduces it, and it doesn't get low. It can never go lower than the base score. And there are some negatives here somewhere which you have to get rid of, but it'd be better if we didn't have negatives. Collect 3. Please just don't throw them away. Okay, so that works now. That seems to imply he does something. We collected a whole bunch that time. That's weird. Yeah, because we collect until they're all filled at least once. And we're... Come on! No! No, you can't be stuck again. We fixed that. Stupid little bot. Stupid little bot, go away. How can it possibly be worth more to throw it away? It can't be. We have a... Something must have been given a negative value. No. Go to laboratories, not worth much. Go to samples, go to molecules. It's worth 10. It should be worth more. Okay, so connect diagnosis. We have number ID and number 4. Number 6 is worth 13. So let's go back one. So we have 3 now, and what does it say? Connect diagnosis 6 increases our score by getting rid of it. How can that increase our score by getting rid of it? Okay, this is kind of annoying that the Because the scrolling here is bound to this, I can't inspect my values very well. So we're there. So the first thing we do is we have 6. It goes to 13.1. And then it goes away. And then collecting 6 would be 13.5. What is 6 that is so valuable? It has a rank of 1, a health of 1. AABBCE. It can't be possible that getting rid of it and taking it back both increase the value over what we have now. That makes no sense. Why would we have that? We have something wrong with the scoring of samples. If we can't fulfill it minus 100, that's fine. If the sample has no health, then yeah, we do this funny thing. But those all have a health. So it's that then we take the health and we give value based on the health. Half of the health plus the player's sample completeness. And we have to do this because we need both the base health and the completeness value to say here's some value. Completing this stuff is good, but it's always just good to have them. Could completeness somehow return negative? Let's check that out. Sample completeness. Probably not. It can return 0. It's not diagnosed, that's fine. The total is a sample cost. And I have the lower of the sample cost. That's correct because self.storage, self.expertise. I don't have more than that. And that should never be negative. So that should never be a negative value. So this cannot being negative. And we have a score of 10. That's fine. That's the base score. 2.6 is the sample value. And 0.5 is the wear value. How on earth can getting rid of it make it worth more? I can't scroll this up enough to see. I can't see on the screen what we're doing. Because you just have this silly connect. I mean, and that's the turn. I don't know whether I'm giving it up or getting it away, but we have this. We have 13.1 and we have 13.5. And this is weird that, so it has to do something. And the other ones are worth less now because of the ETA value on them. But that's dumb. So it's because of the ETA, the other ones are not worth as much, because it's going to be worth less over there. So the samples, just the samples, maybe that. ETA only applies to the where location, because samples, we have that location regardless of whether we have it or not. We have that value, whether we don't have to get anywhere for it. I should probably keep replaying the same conditions just so we know what we're doing. Okay, that may work. We'll see what he does after this. We managed to fulfill 2 of them. We grab a couple of them. That's good. Analyze. That's good. What we're not doing still is we're not going back to here. And so it's costing us too much time. And it's because our ETA doesn't involve the cost difference. And plus we're only going 1 in the future. 1 in the future is also an issue there. We're just falling too far behind. And I'm never collecting rank 2 ones, even though there might be a value, so we don't take any chances. Alright, so we're not doing so well there. Hello, IKFS. Yeah, Petrosol, I'm just trying to figure out how to manage that, because the way we're doing it right now is in the collecting molecules. What I'm doing is... Where is this? I just check the completeness of each one, but I'm allowing the molecules to apply to all of them. And what I should probably do is apply a total as well. So I hope you understand this. So basically, it's like he does collect until they're all filled. It's more value, but it's not considering the fact that when you give up the molecules, you lose some. And so then they're not completed, and that's why it doesn't fill up more than 1 at a time. Because you have all those empty molecules, and how can I actually do that? We need to have a total completeness value. I'd like to make him go back and forth between the laboratory and the molecules first, though. And I'm wondering how I could do that. How can I make him go... How can I say that being at the molecules is better than picking up a new sample? Or is it? Being at the molecules is worth its health times a half. Oh, we do rank times 4 up here, so if it's a low health, well, actually we should do this. Because most of those rank 1 ones, this is hard-coded, the rank 1 ones, not 10. So it's kind of iffy, it's worth less, and then the actual filling up molecules here should be worth more probably. But we do have to do the total completeness to actually get that into consideration. What is the total completeness worth of this thing? If we can complete more at once, we should actually stay at molecules. That would be more worthwhile. You see, the moment I adjust that, we only pick up 2. And I go back there again. And got one filled. And go down there. Go down to the bottom. No, go down to the bottom, you stupid guy. Okay, so what I should do is that add something here. Right here. So let S equal this, and return S. And what we want to do here is if we have available space, and some of them aren't complete, then there's value in going here. If the molecule is there, which is really weird, and... oh man, what's the best way to do this? Let's do it. Let's figure out which molecules we need first of all. Let's get a vector saying which molecules we need. He can pick up whatever he wants, and we're going to say let need. Need, and this is a costly one, vec. I32. Non-molecule types. And this should probably go in the player's score, though. Yeah, let's just do this. Get needed molecules. Oops. Yep. And this is suddenly a costly one, though. Can I make this return a fixed length array instead? Can I make it return this instead? I'd prefer to have this. And reduce the cost. And we'll just do it again for I and 0 dot dot. Now molecule types. Need. We'll see. It's the exact same thing here. Need I. Actually, this is supposed to be more for sample in self dot samples. For and self sample and sample. Need I plus equals sample dot cost I minus self dot expertise I, the maximum of that 0 dot max, the higher of these two values. And then for I and 0, we have to remove the ones we have. Need equals 0 dot max need I minus self dot store I. Okay, so what we're calculating here is how many molecules do we need of each type, and this would be to fill up all of them. How do we fill up all of these things? And we get that, we fill that up, num molecules. So we calculate the total of all that we need, and minus expertise in each one, because we don't need those. We don't need this I. Oh, we do. We need the I. I don't know what it's complaining about. Or remnants. Then we move the stunks we have in the store, and then we say need. So we need to get molecules. Get needed molecules. Get needed molecules. Good, we have those. It's unused. And so down here what we have, we can check if there's needed molecules there. Let's see how many needed molecules we actually have. So let AV equal need. There must be a way to do a map, enumerate with a value, but I'll just do it this way for now. The molecule types. This is AV. AV plus equals, what do we say? Okay, how did this? Yeah, I want to do the map syntax, IKFS, if there's a map syntax. So I want to map and do the mapping with the index and the value together. I don't know if that can be done. If you let me write this root, I'll see right away. So the available ones that we need are, what do we have? How do I want to do this? I have, how do I do the calculation? If I have a maximum, I need 2, and there's 0 available, I get 0. If I need 0 and there's 2, I don't need them. If there's 2 and I have 2, well, that's a weird calculation. Alright, that's the one I'm looking for, IKFS. I'll do that. That's exactly what I'm looking for. I just got to think of the logic first. So we can write that down there. We can say for... That's okay, I can figure out the brackets. So need for equals need.iter.enumerate .map. Come on. Map index, comma value. It's probably going to need an and in there somewhere. Some. This will be I32. I'll just do it the hard way. There might be a way, guys. If value is greater than self.store or available, this becomes self.available I. Else value. That's what I was looking for before. I never get that syntax right. Alright, 32. So if we have something available, it's good to stay here. So we'll just add that to the score, collecting more, and see if that makes a difference. We have some errors. Cannot find value. Yeah, okay, index. That's good. If and else have incompatible types. Well, of course they do, as I32. I hate that. Okay, that looks like it's correct. This should have actually been already I32. Type annotations needed. Well, this one is one it can't collect the right type. No, it can't figure out what it wants. It's F64. It's having a, I don't know if you noticed, I guess we started doing this because it really can't figure out what it wants here. We should probably make this all as F64 as well. And this is what I'm surprised with. It really can't figure out that it wants an F64 here, even though the internal types are all F64. Where are those unnecessary ones? Whatever, let's get rid of those. And use variable r. Where do we use r? It's fine, let's just get rid of it for now. Well, it should know because it's summing up F64, right? Like, look, it's F64 in here. It should know it's F64 because that's the only type it has. The only type it's getting is F64. Same with up here, and that's why I'm surprised it doesn't know it's F64 because it's the only type I'm using. I don't type an F32 anywhere. Oh, it's getting that. Okay, that's probably why then. Uh-huh. That would make sense. Kind of annoying, but... Alright, I don't know. Let's see if this actually changes something. So basically what we've done is said if there's something available, we're going to grab it. It makes sense. It has value to just grab stuff that's available. For whatever reason, we still only grab 2. But here we're going to stay here until we grab a bunch more. That hopefully fills up 2 of them. No, but we basically have it almost filled. We don't go back there yet, which is unfortunate. But we stay here a bit longer. No, we don't stay any longer. How we went back. Surprising. And then we went... What the hell are we... No! Oh man, these scoring things are... Score-based solutions is more difficult than I thought it'd be. So we walk back and forth, we bounce back and forth, so we have 2 things that are worth the same. Because we don't value the doing something. There's something wrong with the ETA. Our ETA has to be higher. ETA has to have a pretty bad score. Because doing something has to be worth more than walking. And I'm trying to figure out why that would be the case. We want to have ETA in the scoring, and I don't have the full ETA yet, but we have a 1. So the ETA we just give ETA of 1 for everything. Right, and this is in the, right here. If we go to, we just give an ETA of 1. And that should be enough to tip it off, because some of the values are actually 1. I think. Our lowest value is 2. So we can just say 2 at least. We can at least put a 2 here because that's the lowest value. And that might or might not help. I don't think it's going to be enough to help. So I try to think of something with our scoring. Picking up a sample has to be worth something. Has to be worth something. This is what's bugging me. It has to be worth more than walking. And picking up molecules has to be worth more than walking. Let's try that. That increases the timeout to at least 1. Or increases the score decrement because of waiting. I feel as I'm just kind of going in circles. So I picked up more of them now, which is interesting. Well, that was like the stupidest thing in the world. Why is that worth anything? It's all like worthless. Why is that worth anything? Why is going to the turn, go to diagnosis. That's fine. I wait. Go to guy laboratory, go to laboratory. How can go to laboratory not be worth more? Am I stuck with something that I can't actually fulfill? Hello? Cursor. AAA. C. Why does he not pick anything up? It should be picking something up there, so the value of picking it up, the value of a fulfilled sample is not enough. So somehow our filled samples are still not worth enough. And I'm wondering how systematic I have to be here in going through and valuing all this stuff. Let's go to the high-level score function and think about all the scores in itself. If we can give something in a laboratory an actual score, what should be the basis for that? Actual score is worth, if we make it too high, let's pump it up and say an actual score is worth something. Good. Right, so 100. That means going to the laboratory. Actually, let's leave it back at 10. And I think this issue there is going to the laboratory, sample health times 10. Has to be worth that much because, yeah, we're fulfilling it. That's an actual health. That's equivalent to health. So going, when we have any fulfilled ones, it's worth that much. Maybe slightly less. It's equivalent to scoring. The ETA is going to apply to that as well. If it's not complete, it's worth nothing to go there. And we sum those up. Good. At the samples one, not having enough samples. That has to be worth just as much as one score is filling one in because that's the minimum rank. And it's the same as diagnosis, I think. If we have, and it's going to be slightly less, we'd rather pick one up from there, and later we can calculate whether it's valuable. We want to discard ones we can't fulfill. Okay, in molecules, completeness. And completeness has to be worth 10 again. It has to be worth the same as a value. Anything is complete, we have to complete the healthiness value there. Good. I think maybe I have too many values. And enumerate the map, anything available. As long as we have stuff available, we should keep collecting. And that's not going to be worth enough to keep collecting, though. But because this is the same value as a laboratory, this might give it a slight advantage to stay here for a little bit. Alright, that might maybe do something. I just picked up 2, and I threw it away! Damn it! Why is it throwing it away? Because they're not worth enough. And there has to be like some hard-coded value that's just having a sample has to be worth something. Can't fulfill the sample, we throw it away, that's fine. Well, IKFS, I was thinking about that as well, is if we had the full game emulator, all these values, I think I'd actually stick them in like perceptrons or something, like little neural network, and actually let it figure out the values for this stuff. Because it's something the computer's actually much better, more efficient at finding than we are. Just let it run a million iterations or a billion of them and find something that balances. But we'd actually have to have the game here to run completely. We almost have the game, but I have to complete the scoring. And so I don't want to, I'm trying to avoid doing that. But maybe during the scoring, maybe I have no choice. Maybe if I do scoring, I have no choice but to simulate the game. I think they have their code. We could actually use the Java code and go back and forth, but that might be too slow if we have to go through the standard input and parse it. Or that shouldn't make a big deal. But why is this not working? Why? There can't be any possibility that giving one up is somehow worth more than moving. Molecules is worth 0. Molecules is worth 13. The hell is that 27 coming from? Molecules aren't. Diagnosis is somehow overvaluing itself. The connecting, the score connect is, what is this? Go away. I'm just not getting this. Why is, on the turn that we go to the molecules, he's actually come after the fact, so this is the value before it. The where is the biggest thing. The where is our problems thing. I mean, sample is okay. Diagnosis is worth a lot. If it's not diagnosed, then we give it a rank, and that gives it a value. Good. If we can't fulfill it, then it gives it 100. Why is it getting such a high value here? It's mapping it too high. It's because of this. If there's nothing there to collect, well, let's just screw it. Let's not collect samples from there at all. Let's go to the samples machine the whole time, and then we'll have to figure out what we do with that. Let's hope for the best. Okay, undiagnosed samples should probably have priority. I'm doing shit again. I'm getting a little bit frustrated now. I can't figure out what it is. I have nobody to be mad at but myself. If it's not diagnosed, the rank... If we have something not diagnosed, this has to be worth quite a bit to go there. Undiagnosed stuff has to be worth quite a bit. Let's just make it priority. As long as we have undiagnosed stuff, we go there. But no, but we're not going to collect more than shit. No, we can do that. We can do, as long as we pad it with the samples, make it the same value as samples. Getting samples is worth the same as undiagnosed. It's a good place to start. And why would he go back and forth though? Because he doesn't have enough. He was able to fulfill it. Without making progress isn't much fun to watch, is it? See, there's... He's throwing him away again. Alright, I'm getting stuck in a loop here. And as I knew our scoring would be bad, I knew it would be hard, but... Damn it, it shouldn't be this hard. Maybe we should have scored the turns instead of scoring the actual state. Alright, I need to work on this a few more minutes. I think I might have given up. I might just be getting lost. I might have to take a fresh look at it tomorrow. Turn, go to the laboratory. Connect. Connect is worth too much. These things to connect is not... Connecting 2 is bad. We throw it away. Connecting 10 is not worth very much. Going to molecules... Clippy. What's Clippy? Horizont. No, I'm not. I'm just frustrated. Usually when I sit here and type, I honestly just sit here like this the whole day. For the show, I get a little bit more excited, but usually I just sit here and like this. I'm having a hard time getting these values to the right place because the stupid movement to the other places is killing the value. What if I just ignore the movement cost again? Some more again. Make it go cleaner, okay? Do I really want it? Let's get sidetracked for now. Yeah, let's do this. Let's do cargo install Clippy. That installs a lot of stuff. My goodness, what have you done? That is a lot of crap. So we're just going to install Clippy as a nice sidetracking thing here. And then we have to figure out the scoring. And the scoring is really bugging me. I don't know why it's just doing back and forth. I have something fundamentally wrong in the scoring that's... Especially giving up that thing. The reason he gives it up is because it's just... moving is just not worth as much. But being at the diagnosis has to be worth absolutely nothing if everything's diagnosed. Maybe that's where I have the error. Can I check that? No, it's worth nothing. Being at diagnosis is worth absolutely nothing. Uh-oh. Alright, so Clippy doesn't compile. So much for the Clippy adventure. That was a short sidetrack. I don't want to switch to nightly though. The reason is because edA-qa or coding game doesn't use nightly, so I might inadvertently use features that aren't supported here. Just for the Clippy? Alright, let's do that. Cargo plus nightly install Clippy. Alright, what about these molecules here? So maybe we're some. Okay, got it. And, okay, so molecules, why is it worth this? Let's let it compile there. Go to molecules has to be worth more. There's something wrong in this diagnosis. It's returning... It's not returning the values I'm expecting it to return. Because diagnosing stuff isn't worth as much. I think we need some baseline values to say something diagnosed is worth more than something undiagnosed. So let's just go stick that in somewhere else. Well, it has a sample health. And this has to be, because the rank is worth, it has to be at least more than that. Come on, the health has to be at least more. Alright, we're going to see Clippy, see what it does, and I'm going to... I was hoping to do a lot better, but I'm doing so bad in the scoring. Still collecting 2. At least he moves on now. And he's stuck in that loop again. Okay, so the scoring, I'm going to really have to fine-tune the scoring somehow because it's just not working the way intended. And let's just see if we can do... What type of suggestions? Let's do clear. I can get this all first. Now it returns nothing. Should this return something? It can't possibly have no suggestions, can it? If you have any ideas, I highly doubt our code is perfect, so I'm guessing we just did something wrong. I'm typing the syntax wrong. Now, what can I do? Samples. Well, this might be the one I need to actually break out the paper for, so I think I might change the file slightly and do it again. Does it use a hash or just the date? Just the date. It's good enough. Yeah, we know it's unneeded return. We had this issue with the unneeded return, and there's a reason why I do this. We had this discussion before. Oh, we need, Nickez, we need to run it with the nightly version, or maybe that's enough. We'll see. We had this issue with return here. We don't know what the best strategy is here because I have an early return, and I have this feeling that if I have an early return, I should have a return down here. But if the standard is to say this, then I can go with that. I don't like it necessarily. It's inconsistent. And it's the same thing on 83. Is we're just being consistent. As long as I had an early return, I was doing return at the end. But let's satisfy Clippy. Maybe this is the correct Rust way. And that appears to be most of them. I don't necessarily like this style, but I don't have a lot of opinions either. Unused is kind of the one. It gets really picky about it, but when we're debugging code, you're going to have it very common. The loop variable I is used to index need. What is this talking about? Yeah, it is. Why is that a warning? Why on earth do they consider this better? Does anybody know Rust? Is this actually considered better form than just doing a for loop? Is it really though? Because the problem then is I'm going to have to do a bunch of unwrapping. Or maybe not. And all right, well, let's see if we can write it. For I need in need.itermut enumerate take just call it nd well, that gives us an error, so we have to figure this out. Point two need. I hope that's the correct way to do that. So we have the same thing down here. Maybe faster, but I don't necessarily find it cleaner. What's the difference between as and from? Anybody know what the difference between this is? Have we been using the wrong type the whole time? Yeah. So we may have actually made it slower for release or debug. Is F64 from, is it like a safe one then? It's not lossy? Okay. .103. Um, 213. Byte A, I guess. I guess it's ASCII then. So Zaglev, if it is lossy, does it throw an error at runtime then? Or does it just ignore it? .259. Oh, we didn't even type that code. .261. I can ignore that one for now. I don't want to mess with that too much right now. Let's do something else. Okay. Probably. Unused, unused, unused. Okay, I think we're good with that. We don't use range now. Let's just get rid of that one. It's causing a lot of issues. Let's go to terminal. Let's rerun Clippy. Five, 4, 8. That sounds like an interesting one. What do we have there? ANVEC instead of AN involves one more reference and cannot be used with non-vec based slices. Well, I don't understand slices, so this is better. No, it accepts it. I'm going to go with that. This is more of an interface than is a slice of turns, and vector can become a slice, I guess. 5, 3, 8. A lot of these things now. 5, 3, 6. Okay, I guess I got it. Yeah, that makes sense. Can't possibly be imagined it's any faster, but it supports more types then, at least. Okay. None of this is going to help our robot, of course, but at least it gives me a small break from whatever I'm actually doing, and the frustration of the robot. We'll finish it up this way, and Clippy has a lot to say. Well, this is new pattern. So this is a new pattern for us that we haven't learned. It's new. I'm hoping this doesn't break anything. 494. Now, is this one going to complain about us? If you said this is compile time error, this should actually not be allowed. If this is... Okay. This from... I'm not understanding what it's doing then. Because sample rank is an I32, and times 4... Or wait, no, an F64 has 48 bits of magnitude, so it might still be okay. But an I32 times an I32 doesn't fit in an F64, so I'm uncertain about this. I'm really uncertain about it, what from is actually doing. $475. Terminal doesn't have a copy link. You know, I don't think it's fixing it, but I'm just trying. I agree. It prevents it from being lossless. So it's basically saying as long as this is an I32, it'll convert correctly, and that's valid. And that's I had a complaint with that before. I didn't like using as, and if this addresses that's good. What it doesn't say is that this could technically overflow and that's a runtime error, but that's not part of the conversion. And 471, so we have a lot of these things. And what is this thing here? Whoa, we have a different one. You seem to be trying to use match for destructing a single pattern. Consider using if-let. Let's do it. Let's use an if-let. We haven't used one of those yet. I've seen it before. No, we're not. We can't use an if-let because we have to actually return a value. So that one is actually, I don't think, correct. I wanted to use an if-let, but yeah, but what does if-let return? Actually, we're not returning a value. Sorry, we're not returning a value there. That's totally correct. We're not returning a value there at all. We're just not returning a value. That's correct. If let we have... How does this actually work, the syntax here? It doesn't give us a recommendation. Well, in this case, this is a simple case because I only have one anyways. I can just do this in this case. I don't even need the let because it's just not doing anything. Okay. But the issue here is that actually that's not what I want in this code. I actually do want this match because if you see this match up here, we are actually multi-matchable patterns, and the value of having the same pattern as above I think is more than trying to reduce the code here, because technically we have the same pattern. It just so happens that we only ever do one module. So I'm going to ignore that one because I actually find this code to be cleaner. 317. That one I don't care about. Zero plus I, yeah, okay. Yeah. Again, this is an issue about clean coding that I'm not certain. Because this is a base index. We're doing a base index plus the offset. And it's really unusual if you just have an offset. This would imply that's all there is in inputs. But this is not the case here because we actually do the exact same pattern down here where I do 5 plus I. And this is again the offset plus a value. And so here I technically think it's more correct to leave the 0 in. So I'm not going to do that one. .277, but we can clean up every other one it recommends. And okay, so we have those few iterators. We can get back to them later, but I think we cleaned up a lot of them. So there's a lot less here. Iterator, we can get back to doing those iterators later. I'll do it later. And then I just disagree with the other ones being necessary. 305 is still one. I just forgot to save it, so we have those few iterator ones, and just the iterators, a few unused, and we're just marking them unused because we don't use them yet. And I guess we get rid. No, I don't have a problem with if-let in general. I have in this scenario here. The issue is this scenario. Yes, but what I'm saying is that just in this scenario, if I had to use it anywhere else, that'd be fine, except I have a pattern here that these two branches are doing the same thing, and there's a lot of value in actually having them have the same syntax. Because if I change the syntax here to be an if-let, it implies I'm doing something different than right up here, but I'm not. It's just an accident, and it may actually change. It's just an accident that this one has only one branch, and this one has 3. And since I can't use if-let here, I'm just trying to be consistent and say, well, I'm not going to use it here either. Because these are following the same pattern, and I prefer the pattern in the code rather than the shortened syntax. Otherwise, definitely I'll use if-let wherever else I can find it. That makes perfect sense. Yeah, you're allowed not to agree. Clippy doesn't agree either. So same with the 0 plus I. It's other ones. We made a lot of changes for it. Let's save it. Let's make sure it still runs, and we still do stupid things in the code. And the scoring, I think I'm going to call it a night. The scoring, unfortunately, we didn't get this. We proved that the scoring system can work. Like, he actually does stuff. We do stupid stuff, and I'm going to sit down with some paper and work out the values of that scoring, because we need some sort of basis to evaluate this more. Because these states, we definitely have to have states, and I mentioned this at the beginning of the show. It's going to be hard to evaluate a state. What is the value of a state in here? And it's not clear, and obviously we have a mismatch here. We have a mismatch that he's not evaluating the states. Clearly, and right here, from here to here, a state where he evaluates that has to be worth a lot more. But our basis for how we're evaluating isn't very good, because we're basing it too much on the final score rather than on the winning score. And I'm wondering if maybe overall the scoring, the way I'm doing it, so he actually eventually did something which was pointless. I'm just trying to think about whether we should be scoring the moves or the actual state. I thought scoring state would make sense, and I think it still makes sense, but we really have to come up with a cleverer scoring approach. And I think it's going to have more base values. And it's because of the fact that the range on these things, on these samples, is so low. It goes from 1 to 10 up to 50, that we can't rely on them for scoring. The scoring has to be built just on something other than the health. Obviously, high health ones are worth more, but unvalued things are worth less because they get stuck. And so maybe we do have to do negatives, but if you do negatives, then you won't collect any samples. Yeah. So I think I'm going to leave it there for tonight. Sorry I didn't make it further. We got the scoring basically. We showed it could actually do stuff, and we show it makes a big difference. We had some scores. Our last one we submitted was actually 43. And we're not going to do much better, so we're going to leave it at that. And I'm going to go back here, and I'm going to save this, get status. I just thought there'd be something for Clippy, and bad scoring. At least we have scoring, and we know how to change it. We know where to change it. We can see the scoring makes a massive difference. And then tomorrow night, I'll try to work out a bit beforehand what some reasonable score values are, so we can show some progress. Not that you have to sit through a whole episode again and me just randomly flipping stuff, because that's no fun. I'll see if I can get that a little better. I was hoping to get some more optimization things and implementing more stuff, and I was hoping to have the DAT, so I might try a little bit tomorrow. But thank you very much for sitting with me and watching through this. And for the fun stuff with Clippy and all the Rust changes and stuff, we're still learning stuff. So each episode, I still think I'm learning something for Rust, and that's great. And I thank you very much for watching. And if you're not already following me, please do follow me. And then tune in tomorrow or Sunday, and we'll keep working on this. Next week, we're going to start the contest. And the contest is, we don't know, it's some sort of superhero thing. And I think I have time actually to start it during the day even. So I might do that. And otherwise, catch me tomorrow. I thank you very much for watching, and have a good night.